Hello everybody. My name's Greg Nolan. I'm an architect. I'm with the School of Architecture, the Discipline of Architecture and Design at the University of Tasmania. And it's my pleasure this afternoon to talk to you about Tasmanian timber and internal applications. Now this is the second presentation, so for those, there's a couple of you who are here this morning. Some of it's going to be the same, but there's a range of extra things put in, and I've put in extra things about coatings, moisture content, and a few other things like flooring options, which will be of interest to people in the building community or the assembly or the fabrication community. Okay, so first thing, I'm not going to talk much about or show you many technical figures today. There's a few compared to this morning, but since it's Friday and it's the middle of winter and it's almost beer o'clock, I've decided that I'll have as fewer words as possible on the screen. I'm going to say a lot, so generally it's mainly pictures. So if you're after technical information, the technical information is on the Tasmanian Timber website. That's what it looks like. There's a lot of things in the brochure area where you can download information about species and flooring laying and a whole range of other things. And there's a free call phone number, 1300 number. And later on, I'll show you the photograph of the guy who's got the phone in his pocket, so you'll know what he looks like. And so if you need technical information, the site will have a lot. If you need information specific to a project, there's a free call number, ring it up, it'll go to someone. If the question is of such complexity, or generally a high-level architectural or a detailing question, it will come to me eventually, unfortunately, but that's the way it goes. So, the website is where most of the technical information will be. So what we've got today is we've got part one, we're going to look at species and products. So the Tasmanian species, the products and supplies, and a couple of key design considerations around performance and materials. We're then going to look at applications and design. So we'll look at various applications for Tasmanian materials, and we'll look at a series of case studies. The break may go somewhere there or maybe up a little bit earlier, depending on how much I talk and how people are feeling. We'll then have a quick Q&A because there's drinks on from 5. And so depending on how I'm running, we'll either just do questions by me standing here with a drink and people coming up and asking, or whether we'll just stand at the front and take some questions from the room. Okay, so why are we interested in wood? So why am I interested in wood? I mean, I'm an academic, I'm going to get paid anyway. So I'm also, though, interested in sustainable development. So there's a basic thing, is that if we're interested in sustainable development, it requires that we have an increased reliance on renewable materials, renewable resources, and that we have some economic withdrawal from non-renewable ones. Now, if I was doing this in a lecture, I would have Australia's greenhouse gas emissions chart as a precursor to making this statement, just to show you what our greenhouse gas emissions are doing. But I don't think we need to here, so that's just a point of view. Now, if that's what we believe is a sensible course of action, we've then got to look at what renewables are. So renewable resources are those that return to their previous stocking levels after exploitation by natural processes of growth or replenishment. So if we deal with replenishment first, that deals with things like wind, solar, wave, geothermal. If we're looking at growth, we're talking then about a whole range of organisms that we grow, we harvest or we use, and we then get that resource out. So, and that's really the topic for today. So organisms are renewable resources that regenerate and regrow to provide us a whole range of materials. Now, whether it's wood or grain or fibre or meat or fuel, we grow these things and we use them. And the organisms have genetic diversity, and we exploit that genetic diversity then to give us different things that we want. So shortly I'll talk about species. Now, each one of those species is a genetic organism. It's a bit of genetic code for a tree of a different specific type, and that genetics will then give us the characteristic of the wood. That'll give us the base characteristic, then we'll grow the tree in a particular place, and the nutrients and sunshine of that particular place will influence it, and then we'll grow it for a particular time, particular spacing, and that will give us the wood we're going to use. Now, that all sounds great. So what has that got to do with architecture and building? Well, the key thing is that when we're dealing with most building materials, we're dealing with things that are not renewable. We're dealing with things that are man-made. And when we make them with a high energy process, and we make them for a target use. So if I want to buy glass, I'm buying glass from Australia, I'm buying glass from China, I'm buying glass from Sweden, and all that glass will be the same. I can have a technical specification, and that glass is what I'll get. If I want aluminium, I can do exactly the same way. But if I go to China and ask them about their trees are going to be different to my trees, and they're going to be different to the trees in Sweden, because the genetics are different. Therefore, if I want to use the trees in Sweden or the trees from China, I've got to actually understand the characteristics of those trees, and that's what makes using timber A, so interesting, and B, so tricky. Because we'll get two species that will come from different parts of the world or from different sides of a valley, and they'll be quite different, one to the other. When we deal with steel, we're dealing with this relatively amorphous, carbon intensive, but that's beside the point in this argument, a relatively amorphous, standardised thing we can pick up everywhere. So when we deal with wood, we've always got to consider what the genetics have wanted to do. The tree has wanted to live, and we've wanted to get wood out of it. So the tree then has different stages of life, and it makes different wood at those different stages of life. You know, it's not like you go to a steel plant and you say, I'll have some juvenile steel, please. You know, I only want the old growth steel. You know, it doesn't quite come off the tongue exactly the same way. So when we look at materials, and when you think about how you're designing things, you've got to make that intellectual jump from, I'm dealing with a plastic that's exactly the same as the plastic from every other plant. With the wood, you're dealing with a particular piece of wood that's come out of a species that has particular characteristics, and each piece is technically unique, and it's all as unique as any one of us. And then someone has harvested it and sorted it for you to use. So, but that will keep on coming back. That's part of the reason that wood technology is quite tricky, because you have all this variability. Okay, theory's over. Okay, so if we look at Tasmania's resources, I'm going to move away from the lectern occasionally, and I'll try and speak up. If you can't hear me at the back, just wave, and I'll come back, or I'll speak louder. Okay, so a lot of the species we're going to talk about today are native forest species. So this is a native forest. I think this one's somewhere up near Smithton. The trees in here have evolved for that location. So what happens with native forestry is that a site is harvested either selectively or in parts or cleared. The seed is collected from the trees that have felled from that place, and that seed is what's put back on the site. But the logic being is that if you do that, the trees are well suited for that location, and they're well suited for the biodiversity that's going to be in that location. So these trees may have regrown after a harvest event, they may have regrown after a big bushfire in 1910 or whatever, don't know. So, and in here you've got lots of different species all standing next to each other. They will have grown maybe at different ages, and they'll have been growing at different rates. So this eucalypt here will be different than that species, that tree there, that'll be different to this one over here, maybe. Maybe they're a bit more regular. This over here is a native forest that's been swimming for about 40 years. So this is another resource that we'll speak about today. This is a dam where the forest there was inundated. The trees are underwater. They've been under the water for as long as it's been dammed up. And then one company is coming along and they're harvesting those trees and bringing it out and making board out of it. Things like this. Okay, so that's a resource. And this is a resource. Obviously, this resource is not growing, it being underwater, but this one is. So here's two more resources, and these are plantation resources. So the difference with a plantation is that you're actually selecting the tree you want to plant. So whether the one on the left is probably a blue gum plantation or a Eucalyptus nitens plantation somewhere up on the northwest coast. I think that's a bit of farm forestry one that I photographed a couple of years ago. So in that case, the seedlings are grown and they're selected for growing quickly. And they're selected for growing straight, and they're planted out at particular spacings. So it's not like a native forest at all. It might look relatively natural if someone's come through and taken out trees at an irregular basis. So they're evenly spaced, more like a park. Okay, but the trees will actually be grown from selected seed, and they'll be generally all of an even age. Now, in the state at the moment, we're harvesting probably 2.8 million tonnes of that stuff. That's a lot. You don't see it much at this end of the island, but if you go up to Burnie, you'll certainly see a lot of it, right? There's probably, well, there's a lot going out of Burnie at the moment. So we're not going to talk about that much today, except for me to say is that there's quite a lot of people putting quite a lot of effort into working out how we can get some of the products we're going to talk about today and other products out of that material which is currently grown for fibre. So when they've grown that, they've put it in the ground, it grows really quickly. They're not interested really, they were not originally interested in solid wood products. And so it's all grown to, lots of trees about yay big. In 18 years, it's all harvesting, all being harvested, and now it's being exported. A whole range of people are doing work, including ourselves, to how we convert this into solid wood products. Maybe not the same as what we're looking at today, but they'll be certainly complementary to the things that we're looking at today. So if you're really interested in that, there's probably one miller who's got some in their kilns at the moment, but that's an experimental exercise. So there is some available, but there's not enough to do, there's not enough for a range of producers. The next is this one, which is radiata pine. So just to put it into context, we're currently harvesting about 450,000 cubic metres of pine sawlog a year, most of which is going to one mill at Bell Bay, most of which is then being turned into scantling or framing sizes. So they're a big, highly efficient, very competent mill, and they're turning that into framing material which is being used throughout Tasmania and interstate. So that's our resources. The ones we're going to speak about most are the ones best suited for internal applications, which are mainly the ones from native forests. But the plantation hardwood stuff will come on stream across the next couple of years. Okay, so if we look at Tasmania species, here's a quote from a 4th generation sawmiller who didn't know he was making it at the time, which was basically that the colour offerings in Tasmanian species is as good as anywhere available in the world. You've got blondes, you've got rich and dark browns through Blackwood, you've got some small volumes of myrtle, and they're similar to what you can get in other places. So that gives you a perspective. We want to look now at some of the species themselves. So this is Tasmanian oak. This is the bulk of the market, the bulk of supply. So I've got some samples here which I'll pass around, just so long as we can get them back at the end. So these ones with the nice black stickers, they're hydrowood. I can't tell you if they're Tasmanian oak because underwater you can't tell. And when you bring them up, you can't tell either, because the only way you can really tell is from the leaves and the bark. And when it's been underwater for 40 years, there's not many leaves and there's not much bark left. So, but they're eucalypt. So we'll pass 2 there and 2 here. And this is other Tas oak. This is normal material. It's dressed on 3 sides and it's undressed on the back. So I'll just pass those around. Now, any of you will have been to or been past a sawmill will have seen the timber like this. This is timber that's called in rack or stacked. And this is what it should look like when you're trying to dry the material down from unseasoned, straight cut out of the tree, and then you're trying to get it to a condition where it's stable for use in buildings like this and in high-grade applications. I will talk a little bit more, quite a bit more about drying later on and moisture content control. One thing I will say is that when they stack these up, there might be a particular height to all of the stacks put together, and as it dries, the stack will shrink. So it might be 1/2 metre lower at the end than when it goes out, because as the stuff dries, it does 2 things in Tasmania. One, it shrinks, and the other, it collapses. There's a thing called collapse. And then you steam it up and it pops back up again. But it shrinks quite a deal. So here's the material in rack, but then it's converted into products like this. So you get, with Tasmanian oak, it's actually 3 species together. It's Eucalyptus obliqua, which is the bulk of it. In Victoria, that's also called messmate. There's Eucalyptus delicatensis, and there's Eucalyptus regnans. In Victoria, regnans and delicatensis are called Vic Ash, and here we blend all 3 together, because our species, while they're the same species, have different growing conditions, so they're actually more like each other than they are in Victoria. So it's pale coloured, and it takes a coating and a stain quite well. The next major grouping is Blackwood. So here's some Blackwoods. Blackwood is an acacia, it's a wattle. It's the most popular of the wattles. There are some others that are not as readily available in volume. You've got this really nice dark colour to the thing. Again, dries pretty easily, some reasonable volumes of the material around in both normal solids and in hydrowood. Very useful for furniture, very useful for wall linings, and also in floors. Next one for today is myrtle. I'll just get some myrtle. Now, myrtle is an interesting thing because you get the red when the myrtle tree grows in certain locations. In other locations, it is not red, it's pink. And that's problematic for people who are specifying and people who want to sell, because everyone says, oh, myrtle's that colour. You know, it's not pink. It's not pale. But myrtle is pale if it's come from particular locations. This, again, is this bit about genetics and growing, is that you grow, the stuff grows in particular locations. It comes out different than if it grows somewhere else. There's a log there of a nice pink myrtle log, and this is a floor when it's laid. I'll pass these samples around. One thing you can notice with the myrtle is how beautifully fine the grain is. And it's a lovely stuff to handle and to deal with. You get some really nice lustre across the surfaces of the myrtle. Now I've got some properties of these relative species later on. The last one we've got today is celery-top pine. Now it is a pine, it's a slow growing species. So a log about yay big will be about 400 years. So it's very slow growing species. It's also one of the few species we've got in the island which is actually reasonably durable in heartwood, so without the sapwood on it. So it can go outside. It's a durability class 2, I think. 2, 3, it was 3, it was pushed to 2, it's gone back to 2. It's very finely grained and it's beautifully white to start with. After a while, it goes honey-coloured. So after 3 or 4 years, this will actually go back to a colour not dissimilar to that. And after 5 or 6 years in a sunny location, it'll go back to honey, actually quite rich honey colour. So it does vary, but it's a beautiful thing, beautiful species in its own right. Now, because it's slow growing, you've got very fine grain, and if most trees that are slow growing will have things in them, extractives or chemicals that the tree has made to make the wood not tasty to bugs. Because if you're going to live 400 years or 800 years, you don't want to be eaten up at age 60, you know, it just goes against the genetics. So if we look at relative supply, I think you want to take this as more a logarithmic diagram than an absolute one, is that Tasmanian oak is by far the largest supply we've got. There's notionally 135,000 cubic metres of it harvested every year, and that's then available through mills, and that comes out as board, like what you can see over there on the left-hand side. Blackwood, I don't know what the figures are from Blackwood, but it's significantly less. And so if you're going to use Blackwood, you want to make sure you're using it in really fine locations. There's much more Tasmanian oak around. So if we look now at available products from the resource, the first is sawn and moulded material. So, excuse me, I'm just trying to get my... So this is board, dried, kiln dried, standard moisture content. It's rough sawn. It's a bit like the back of all these boards I've shown you. It's come off the saw, it's been racked, it's been dried, it's been reconditioned, put in the kiln. It's probably somewhere between 11 and 12% moisture content, but it's that shape. And that's then a perfect blank to be used then by somebody else to make something relatively glorious. So these are quite large sections, ready for use. It could be moulded into a piece of flooring like this. This is overlay flooring in a big sports job down in Kingston. And you have a whole range of this product which is then available in different sizes. And we'll show you a little bit of that later on, though I'm not going to go into it in any great detail. A next major product group we've got is plywood. Now I don't have any samples of the plywood with me, but this is peeled oak veneer that's peeled at Taran's mills in either the south or the north of the state. Taran has then put in a plywood pressing line, and that's a part of it there on the left. So when you want to make plywood, of course, you've got to peel it first. It looks like this. You've then got to dry it. It's graded. You arrange it. You've then got to put glue on, press it. You press it once to keep it get it to effectively the right shape and size, and that's what you do in this one on the left. Then you put it in another press that puts in a lot of extra pressure, heat, and time, and then you end up with the solid plywood product. So that's one of the products then that's now available. So most of it is going into form ply. That's their bulk product at the market at the moment, but they're increasingly looking at the architectural market to see what sort of products that they can assemble that are going to be useful then for ceilings, floors, lining and joinery. So there is another sort of veneer product, and this is appearance veneer. So I've got a piece of appearance veneers here. These are from speciality veneers. Okay, so these are, we've got a black heart sassafras, we've got an oak veneer face. So what happens to manufacture these is that you'll get a billet of wood, so a relatively large bit, or something of this order. It's then either boiled or steamed for a long time to get the wood to be very, very soft and almost spongy, and then it's put through a slicer. So the slicer then is just like a meat slicer, and it gives you about 0.6 of a millimetre thick material, which then is bundled up, joined together into a sheet, and then applied to a substrate. So this substrate is often medium density fibreboard, and there are people in the north of the state who will actually who peel and later board. So you can buy the material from them, pre-milled, pre-laid up in the mill. So there's someone here from the company, or someone's here from the company, and they can speak to you in the break about the supply of species that they have and the board that they lay it on. So there's two producers. They're one, Britton's Timber at Smithton is the second. So when the stuff is sliced, it's sliced into a bundle. So this here is a bundle, and so each piece is collected in the same order that it's sliced off the billet, and then you rearrange the pieces so that you get the grain marrying up across the piece so that it all looks very calm or looks very dramatic, depending upon how you want. Because this is all a natural material, it's all, different organisms, they've all grown in different locations. Every miller, everyone who produces a wood product has to grade, which means that there's a definition of what's allowable in different batches. We tend to have grade definitions which are based upon a relatively elitist terminology like select, which I find abhorrent because I tend to like character in the wood rather than it being relatively bland. I mean, this is just a small piece, so it's easy to pick a bit that doesn't have feature in it. But everybody who works in the industry will grade things to give you visual groups that are acceptable. Now, if all your default is select, then what you're not going to get is you're not going to get the serendipity of a feature like this appearing in a nice spot where people are going to walk past it every day. You're going to get something that's going to look more and more like plastic and less like something that's been alive. Now, as we get more and more connected to big cities and plastic surfaces, etc., finding things like this becomes more and more interesting. It's more and more grounding for people when they can see such a feature like that. So this one is gum vein. We'll talk about features later on a bit more. So that's gum vein, there's gum vein here. And this one across here, this is a veneered piece. This is called black speck. So black speck is from an insect. And you can see how the pattern repeats because it's been through a billet this way, and then the billet's been sliced, and then the pieces have been laid out next to each other, and then reassembled on the board to give you that line. So there hasn't been a craftsperson there sort of neatly putting black holes in the piece. It was some useful insect. So if we look at things that then determine a visual palette, is we have colour, which is often species determined. So a species will generally have a particular colour or a colour range. We'll then have grain, and grain is that combination of how the cells run across the piece, whether the grain is big, whether the grain is fine, whether the grain is a little rippled, so you get a rippling effect in it. This is a piece from a big eucalypt burl that's been growing on the side of a tree. There's then feature. And of course, this feature here is gum vein. We can see that mark down there. Some of you might think, God, this is rubbish, get rid of this. And others of you might think, oh, this is great, where can I get some more? We can then combine different things together to give us a particular view. If we look at features per se, here's our gum vein through here. This is the black speck I was talking about earlier on. So these marks there, they can look haphazard. If we save all the pieces in the bundle, we can then rearrange them. If we've got it in solids, we can actually match the solids up to make large pieces of furniture out of it. This is called gum cluster, where you have little growths of the wood that are forming small burls in patterns. And this one here is called black heart. Now black heart, I've got some here. In eucalypt we call it stain, and we try and get rid of it. In sassafras we call it black heart because of its relatively striking characteristic. So that's caused by a stain that's come from generally a broken branch high up in the tree, which has then caused a stain which has run down inside the wood and stained the timber. That's all black heart, and that shows you the characteristic. So sassafras, of which this is part of the species, is normally this colour. So normal sassafras is that pale brown. The black heart then is this part there. And it's really, really good if you give it to a designer who knows when to stop. If you give it to a designer who doesn't know when to stop, it's sort of like, you need to put your sunnies on. So, but all of these then are features. They're all, people say to me, oh God, look at all the defects in this thing, Greg. And I say, don't use that word. It's the wrong word. Okay, so we look at product to supply and quality. How are we going for time? All right. Quality Tas oak and blackwood especially are readily available, domestic markets, commercial, domestic fit out, and for furniture. These are just photographs from a hardware store. So you've got moulded material here in racks. You've got stuff which has been put back together again to form slightly bigger sections for use in benches and potentially for structural products. You've got then here a whole series of different profiles that you can buy from the hardware store. So there's a ready supply of material. If you're into a larger project, there's then particular supply you can organise with the producers themselves. It's not a case anymore where you've got guys, it's always guys, in leather aprons, tossing logs back from one end of a saw to another. I think we got rid of one of those, the last one, some time ago. If you've got a phone query, the phone query goes to Mick. So that's Mick. So Mick used to work in one of the larger timber producers. Actually, he worked in research first. Then he went out and worked with producers, and now he's back working with me at the university. So in Mick's pocket is the phone that the 1300 number goes to, and if it gets down to an email, that email comes to me. So Mick's role is basically to be the technical library for the production sector and to work with millers to ensure they've got good quality production, and he also does the quality assurance program. So there's a quality assurance program where Mick comes around and checks to make sure at regular intervals that the production meets the requirements of the standard and the requirements of grade that is put out into the public domain. So instead of people with simple saws anymore, there's then a lot of high calibre equipment with laser sights on them to make sure that things are being cut exactly the way they should be and that they're being cut for recovery. But even though you're getting this level of equipment, you've also then got family backgrounds in the companies. So you can easily approach the people who are making the wood to get background information and support. So the happy group in the middle, not the two unsightly ones on the outside, the happy group in the middle, they're Masters of Architecture students from the University of Queensland who came down and they wanted to see where this wood stuff came from. So we rang a few people, arranged some trips, and obviously they've gone to the mill, they've seen what's being done, they've looked at the racks of stuff that's readily available, and they're having a good time in understanding exactly what this resource is. So the stuff comes, it's locally grown, it's then also relatively locally produced. So while they're family companies or relatively small in a conglomerate size, they're still approachable, but they're still technically competent. I think that's an important thing. Okay, one important part of product quality is moisture content. Now, this morning we didn't deal too much with this. This afternoon I want to deal with it a bit more. One of the key issues with wood is that wood is what's called hygroscopic. That means it gains and loses moisture to be in equilibrium with its surrounding environment. When this is in the tree, it might have a moisture content of about 100%. So 100% moisture content means is that you've got as much dry wood fibre as water in a piece. So if this piece weighed 2 kilograms with 100% moisture content, 1 kilogram would be water, 1 kilogram would be dry wood. So that's what this diagram's sort of showing. That says 1.12 kilograms. That gives you 1 kilogram of dry wood, 0.2 of a kilogram of water. That's about what moisture content this would be now. But it isn't when it starts. So what happens is that you have a cell and the cell is full of water. That's called free water. There's then water in the outlying cell structure itself. That's called bound water. The water dries out and then the water comes out of the cells and the cells shrink. So you get dry timber. Now, if you put that dry timber in this beautiful museum where the inside moisture conditions are being heavily controlled, the timber will give out moisture to be in equilibrium with that environment. If you take that same piece and you put it outside, then it will take moisture in and that will go into the cell structure. If you put it back in the museum, it will lose it again. Now, that's all very fine, so why do we care? The key thing is that as it gets bigger and smaller, as it gives moisture up and takes moisture in, it gets bigger and smaller. And it gets bigger and smaller in different directions by different amounts. So it will vary longitudinally, that's along the cells. It will vary radially, that's perpendicular to the growth rings. And it will vary tangentially, that's around the growth rings. So if we look at mountain ash here, that's one of the Tas oak species. Radially, it will shrink 6.5%, tangentially up to 13%. So if my milling colleagues want a piece that's 100 at the end, they cut it at 115, something of that order, knowing that it's going to shrink that much down as it dries. Now, what that also means is that if I put this in a certain area, a second, I think I've got a slide of this. If I mill this at 12%, which is what most millers will target, and I mill it at 85%, and I put it in a room that's at 9%, like this room would be if they put the heating up anymore, is that it's actually going to shrink to 84.4. Now, for one board, you might think, oh, that doesn't matter. You know, it's only 0.6 of a millimetre. But imagine I've got 9 metres of this stuff. Yeah, so every one of them wants to shrink that much. And that 3%, that could be the difference between summer and winter, or air conditioning system on, air conditioning system off. So this becomes important. When we detail, I'll show you some photographs of what happens. If we don't detail and allow for this stuff to shift, then it's still going to shift anyway, whether we want it to or not. And if we try and hold it in, it will push it will push out. And if we try and stick it together, it will rip apart. So it's fairly inexorable. Next thing is chain of custody. This is another part of quality and part of the supply system, is that chain of custody, forest and chain of custody certification addresses one of the key issues about forests, is that people want to buy wood, they want to make sure that they're not buggering up the place that it comes from while they do it. That's fairly reasonable. You don't want someone come in, levelling something, taking all the trees off, walking away and having the whole place erode. Now, if you're in Sydney or Melbourne or London and you want to specify something and you want to make sure that this doesn't happen, then you call up what's called a certification program. Certification program says we have a standard for forestry practice, and people who comply with that standard, we will give certification to. Then there is, from that forest to a miller, to the boat, to the job, is then a chain of custody of the wood. And you want to make sure that a miller hasn't got 10 units of certified logs come in and is selling 25 units of certified wood going out, because that's corrupt. Okay, so you set up quality control programs for these two things. In both of them, you have a standard by which you're measuring things, and then you have this quality control process of ensuring that this is ticked off against the performance of the standard. So that we have internationally, there's two major forest certification schemes. One's called the Forest Stewardship Council. And the Forest Stewardship Council is an international organisation that has branch offices. I think that's the best way to think about it. Branch offices in different countries, and they all use the same logo. The other one is called PEFC, And PEFC works on a slightly different model. They have a central agency which says this is what a sensible standard should look like, and then different countries will write a standard based upon their own conditions, and PEFC will interact with them to make sure that their standard complies with the overarching principles. And then they'll give them a tick. So if you're in this one, that's recognised by PEFC, which means if you sell this into the States or into the Europe, it uses this logo and it's all transferable. Okay, now there is, especially in the Tasmanian media, there's a lot of dispute about, do I want this one, do I want that one? The real argument is, has it got certification or doesn't it have certification? Because if you look at all the material that's transported around the world, only about 20% of all the wood traded actually has certification. And really what we're interested in is making sure that as much of the wood that's traded has certification and is being harvested properly and responsibly. So that's the major argument. Whether you've got a Ford or a Holden is less of an issue across the two. People ask me, do I have a preference? I have a preference that it's certified. I don't care which. Under the Green Building Council of Australia, both of them are recognised as being acceptable for points. And if you look at the English schemes and the European schemes, both types, FSC and PEFC, are both accepted. Okay, but there's one important criteria if you're calling up certification, or if you've been asked for it, you've got to make sure you've got the same certification along the system. So we've been asked by some furniture sellers, we've got certification on our forest. I says, all right, what have you got? And they said, we've got FSC from the miller, from the forest, and we've got PEFC from the producer. I go, well, sorry, it doesn't work that way. It's sort of, you need consistency across schemes between forest and chain of custody. Unfortunately, if you've got this combination here at this end, is that no one's going to believe you. Okay, so that's certification. The next is carbon sequestration. So the diagram, the slide on the left, the brochure over here, is what's called an environmental product declaration. So an EPD, an environmental product declaration, is a document prepared under an agreed format for life cycle assessment. So 8 or 10 years ago, there was lots of this discussion about life cycle assessment would help us with everything. We could just do a life cycle assessment, it could tell us whether this one was better than that one. And of course, the people wanted that, they just wanted work. However, to ensure that people had decent information, comparable information, under the auspices of the federal government, all major material producers agreed that they would produce these environmental product declarations, and they would prepare all the data from case studies to a standardised methodology, and that they would publish them in exactly the same format, so the same tables using exactly the same headings. So if you do a search for an environmental product declaration, there's a website, EPD Australia, and there's lots of products there with this data available. So they'll compare how much greenhouse gas emissions, all these other sorts of things that come out from every one of the products. This is one from the life cycle of dressed hardwood. Key thing I put this up is that this shows that in the forestry stage, you're sequestering about 1,200 kilograms of CO2 equivalent for every cubic metre of hardwood grown. Okay? You're then expending about 350 to 400 kilogram equivalent of CO2 equivalent in transporting the stuff, harvesting it, all those other sorts of things. Which means, gives you a balance at this point where you're using in the building of somewhere about 880 kilograms of CO2 equivalent for every cubic metre of hardwood you're putting into the building. So that's atmospheric carbon. It's not coal or any of these other sorts of stuff. So it's come from the carbon, it's come from the atmosphere into the wood. So 50% of the weight of this piece in my hand is atmospheric carbon. It's just simple, it's what the chemical structure of the material is. So that's important when you're making a big building. The next thing is that if you're using a wood bit and you're not using a steel bit, on average, you're saving as much again by not using the steel. Does that make sense? So if you had to use an element, you save about as much from not using the steel as you sequester in by using the wood. So if we take for every cubic metre of hardwood we're using in a building, you're actually putting about 1.6 tonne of CO2 equivalent better off than if you'd put a steel bit in. Yeah? So now all these figures are there. You don't have to just believe me. They're there. The steel guys have got their figures. They don't have these little diagrams because they don't necessarily want you to understand it. But they do have all of the applicable figures in the environmental product declarations, which are readily available. If we look at design considerations, and I've got here performance and materials. So there's a difference between a performance requirement, and that's something that you need the material, whatever it is, to do because it's regulated or it's part of the necessary function of the item. So things that you need to have done, you need strength. You don't want things breaking. It's regulated away from that. There's things like indentation resistance. That might sound, terribly unsexy, but if you're putting a floor down and people are going to walk on it all day or run rollers over it or equipment, then you want that thing not to be compressed and break. There's fire resistance requirements that you have that are set by the National Construction Codes. And then there's durability issues. If we look at those, if we're dealing for an interior design and appearance piece, strength is usually not an issue. Obviously, if you've got floors, they have particular requirements. If you've got things you've got people walking up, such as stairs, they do. But generally, it's not a major structural loads like you'd have in the superstructure of the building. Indentation resistance becomes important because if you put a floor down and it's a really aggressive environment, then you're going to have real problems. Fire resistance in the codes, the major ones we're looking at are the basic fire indices that are required, I think clause C10, C1.10 I think, which calls up levels of fire resistance, lack of spread of flame, smoke developed, indexes, etc. The thing with timber is that timber's generally all bunched together. It doesn't matter how dense or not dense the wood is. The staging in the relationships is such that you'll generally find the timber will all be grouped in one group, and generally you can't use it in a fire egress area, but you pretty well can use it most other places. And there's some density split between some species and another, but that can be covered, but it's a fairly technical point. Durability, inside, we're not worried about durability because our major durability concerns are derived from water or insects, and hopefully if we're inside, it's not wet all the time, and we should have kept the insects out. The other thing with durability, and it's a question that came up this morning, was about sunlight and coatings. One thing I will just touch on is that wood is photoreactive, so that if we put this in the sun, and we're going to get a change of colour. It's the first thing. Also is that the sunlight will hit the molecules of the wood and it will break them up. So what we find is that this, if we leave this outside, put it on the fence, it will go grey. And that greying is the molecules being broken down by sunlight and they lose their colour. Now, if we've put a clear coating over that, then what that means is that the clear coating lets the light through, sticks to the surface, but then the surface becomes all chalky and the clear coating falls off. So that happens all the time outside. So if you've got clear coatings, you know, you're used to recoating things. If I put it in a window frame where it's sunny all the time, I'll get my if I'm using a polyurethane finish, I'll find that start to come off after 7 or 8 years. It'll come away powdery. There's not really much you can do about it because unless you can keep it out of the sun. Certain species then will also change colour. We mentioned celery-top before. If we're looking at material performance, which is how does this material satisfy the performance requirements, then appearance is a performance requirement, but it's really up to the designer. We've got hardness, moisture content, and finishes and coatings and stains. I'd want to do a little bit on hardness and quite a bit on moisture content, and not so much on the last one. So this is hardness and recommendations for practice for floors. Okay, there's very, very little, actually no, viable recommendations in Australia for a benchmark of what you should be looking for floors. There's people say you shouldn't do that, but they never say where the boundary line is. This chart from the top is actually from a piece of British research from the Building Research Establishment, dates back to about the 1960s or 70s, that I found when I was doing my research masters. And it gives you levels of traffic and recommended species densities for the British. Now the Brits, they used most of their wood, they were out of it by about 1820, they'd used it all. And so they were great importers. So these were parameters that they would have because they were importing different species. They had to compare it. So effectively, this heavy 700 kilograms per cubic metre, in Australia we would say that's too soft. And we would push that up, especially if you're in New South Wales because they want to sell their timbers. So they will push that up to sort of 800 or 900. What's the density of the major Tasmanian species? This is density figures. And this is a thing called a hardness level. It's called a Yanker test. Basically, you take a ball bearing and you push it into the wood and it dents in. I think it's a 12 millimetre ball bearing. You push it all the way until it's halfway and you read how much force you need, and that's the figure. So obviously, Tasmanian blue gum, which is very hard to get, or is quite difficult to get, is a 10. And you see how much it drops down to Tas oak, blackwood and myrtle, which effectively are very similar with each other, even though the blackwood's got a higher density rating. So if I was being asked if someone's got a big museum to do or something like that, I'd say I'd seriously consider not using Tas oak where you're going to have all the people walking through, where you're going to have trolleys running through all the time, because it will dent. I'd be going for a harder species for there, but in most of my normal areas, I'd be perfectly satisfactory. If in a case like this where you've got tables being moved in and out and chairs and metal fixings, then it's very unkind to a floor, so you actually need something quite tough. So they're the sort of parameters you want to start to think about when you're selecting the materials to use. There's then moisture content requirements. So this is the boundaries set by the Australian Standard 2796 for different applications. That's parquetry and furniture up there at the top, 8 to 13. This is strip flooring and mouldings, and this is decks and fascias. So this is stuff that might be going outside. A room like this is going to have an equilibrium moisture content of about 11 to 12, depending on how much the heating's running. And most producers will try and target a market at 11. So if they are selling it at 11 and it goes to you as a builder and you leave it out in the rain for 3 weeks, then it's not going to be 11 when you put it into the job. So you monitoring that moisture content then becomes important. So if you get the stuff, you have a pack. The pack will arrive, it'll always be wrapped in plastic. So the plastic is your first level of protection of the wood from the environment. So with this primary protection, it can go outside for a limited period of time. If you are going to store it for any longer period, you want to put it in a building of some description, which at least has got a roof and got good ventilation. They're important considerations. Then, depending upon what your role is, you want to actually be assessing the moisture content of the material at key spots in your production processes, all the way through to site. So let's say there's a miller down here, they're dispatching material, it's arriving at a producer or distribution agent, whatever. They want to check moisture content when it gets there. There are guidelines for how regularly you should test it. There is videos on, mugs guides on what you should be looking for and how you should measure it. So they want to do it before they put it into store. They want to do it when it goes out of the store, because it changes ownership, you change responsibility, you change liability when you know it's left your place at the right moisture content. If you'll get a construction site or a fabricator's site, you actually want to be checking it there as well when you get it. And if you're not storing it for a long period, you want to check it solidly, protect it, and then use it. Now, if you put it in at the wrong moisture content, you can then get all sorts of problems. I'll show you one or two in a minute. Now, ways of measuring moisture content. There's two basic methods that are used. One's called a resistance moisture meter. So there's a little diagram there on the left, is where you've got an electrical device, you put two prongs in, there's electrical current between the two and it measures how much will go through. And that will give you a reading. This is another one called a capacitance meter, and you just put it on the surface and it gives you a reading. Okay, so this is where they're accurate, relatively accurate from about 6 to 25, and sort of from 0 up to about 30. They're no good above that because there's too much water in the piece. The water's actually in the cells and it doesn't even make any sense at all. There's a couple of good points and bad points about each of these. This is actually in flyers on the site, so if you're doing timber work very regularly, I suggest you download them, go on Wood Solutions campus and watch the video. The thing is, the resistance moisture meter, the prongs in, is much more accurate than the capacitance meter. But you get 2 holes in your wood. Yeah? So it's more accurate, but it takes longer and it damages the surface. Yeah, well, you can flip it over, but if it's already in the floor, you can't. The capacitance meter's faster, but it's less accurate. Sometimes, though, is that you may know that most of it's all right, but there's a couple of bad ones in there. The capacitance meters will give you a good indication of what's out of the park and what you need to separate off. It will tell you if you've got a problem with certain boards compared to other boards, and do it pretty quickly. So in a number of production facilities, these capacitance meters are used in line all the time just to make sure everything's being grouped up properly. Does that make sense? So I'll show you in a minute why this is important. So if we look at applications, floor and wear surfaces are always obviously important applications. A lot of Tasmanian material ends up in floors. This is sort of like a relatively conservative, non-A architect solution. This one is a little bit more specky. This is a blackwood floor. You can see quite significantly different colour, much richer colour in the surface. There are lots of different options for the floor. You can put boards on joists. So if we work from the top left across, you can put boards on the joist. That's one. You can put boards, smaller boards, and you put it on a substrate. So that's called overlay here. That's overlay on a particle board or plywood. This is concrete with a plywood nailed on, and then the boards nailed and glued to the plywood. This is direct stick, as they call it, which means you take the concrete, you put a glue down and you stick it fully. We could do a full seminar on how to glue them, but we haven't got enough time before the beer gets here. And we can also use parquetry, and of course we've obviously got to put parquetry on something else. If we get it right, everyone's happy. If we get it wrong, people are very sad. And it's very hard to fix. This is a job that we're asked to inspect, and like all jobs where there's a problem, there's generally a problem because of 3 or 4 reasons rather than one. I won't go into what the background of the job is or who did what. Be it enough to say is that the boards were put in and they were, the coating, the boards had gaps between them, little gaps. The coating was put on and it was a polyurethane coating. Polyurethane is a marvellous glue. So the polyurethane got in between the boards, the job dried out, the boards got smaller, people have a wood heater, and all the boards are stuck together. So instead of the boards being able to move individually, they stick together and they move in one spot, and you get this big gap, which is really quite noticeable. That's about 1.5 millimetres. Yeah? And because in this case the boards had been sanded more than once, the top of the board was weak, the shoulder of the board was weak, so where they glued together it actually started to rip the shoulder back here. And these were quite common across the whole floor. It is actually predictable if you do things wrong, and this is one reason why moisture content management and control is really quite critical. We're asked to see, 5 or 6 jobs a year where these sorts of things have occurred. And it's generally due to the builder left the material out in the weather too long, they laid the floor and the roof leaked, someone, punctured one of the plumbing lines and the floor got wet, and they thought they let it dry out, and then anyway. So there's always unhappy. If we go back to some happy things, then here's a job at Pump House Point, and I'll just give a plug, the architect for that's in the room. So things about this is that the architects are deliberately using the feature of the board that's on the back, straight off the saw, and the boards have spaces. So if each board wants to move, it can move quite freely between one to the other. They're not stuck together, they're not glued together. So everything can move, everything can happen. There's not a lot of problem, and it can be very, very interesting. There'd be a coating system on it to keep dust off, but otherwise it looks very attractive. Here's another one. This is attempting to get a different aesthetic. So with this one, you've got boards, and their boards are fixed and battened on the face of plywood. So you put a plywood on first, and then you put the battens over the face of the plywood, so it looks like you've got boards going back in and out. But if you match the plywood with the board in terms of species, I expect this one's also had an evening stain put on it to make it all quite regular coloured. You end up with this really nice layering. You can stain the boards first and leave the plywood a little paler, which then gives you a more harlequin or a striped appearance. And if you do it subtly, it can look really lovely. Here's one where the boards have been left clear, been clear coated, but there's lots of pink in the surrounding environment, around in the whole palette. And so these look much pinker than they do in the previous photograph. I suspect the last ones may have been stained, but these ones wouldn't have been. These are just as they are. And you pick a coating that doesn't yellow up too much. And there are particular coatings that'll do that. Linings and surfaces like this rarely give problems. They're not prone to difficulty so much. There's also joinery in a whole range of installations we can manufacture and use. Some very, very fine surfaces, lots of food venues, and there's lots of really interesting furniture combinations you can put together. In the brochures, there's referencing from particular furniture manufacturers. Here's a problem. So this is a furniture detail. This is a detailing issue with a coating. It's two things. A, it's a coating problem. B, it's a detail issue. And this indicates the complexity but inevitability of when you do something the wrong way around. So what's happening here is that the designer thought, what we'll do is we'll bring the leg of the seat through the seat base and we'll express it on the top. Perfectly logical. Okay, so we'll do that. We'll glue it in and we'll put a nice polyurethane coating over the top. Okay, now the problem is that the top is radially and tangentially moving material, and the middle bit isn't. Also so what's happening is that these bits are expanding and contracting. However, they've been stuck to that bit, and this bit, wood across the grain, is much weaker than wood along the grain. So this is binding into there, and it's literally pulling the top apart, pulling that top of that board in and out. So here you can see it's adhered, and then you've got a space, and here you can see it's adhered and it's ripped that bit off, and here it's ripped that bit off. We had to do an inspection of this job, and we worked out 1 in 4 was split after 2 months. So these are the sorts of detailing issues that with furniture, etc., you've just got to be careful of. It's in part a moisture issue. How are we going for time? The beer's not out yet, so. Okay, so I quickly wanted to have a look at a couple of projects. This is a nice little job by Liminal Studio. This is Freycinet Lodge Coastal Pavilions. So they're small rental accommodation, small accommodation that you can get up near Freycinet. So what we've got is we've got plywood here, plywood on the roof. It's Tasmanian oak plywood, and it's been stained. We've got solid Tas oak that's been used in staggered boards around the surfaces, and that's also been stained back. And then we've got veneer in blackwood around here with solid edge trims, solid blackwood trims. So you get this very nice even brown look through there, and this is the bedrooms and other spaces. So the plywood matches, is a very good surface material. it can match in colour then exactly to the lining that you put on the wall. This is, all very nice brown. Let's go to a much funner thing. So here's what's called the Dowell House in Victoria. And in it, it's a traditional Victorian house problem. You've got big rooms at the front. The kitchen's this little lean-to at the back. People buy it and they go, right, we've got to get rid of this kitchen, make a decent kitchen and a living space. And so that's what they've done. Here's the hallway, new timber floor. Kitchen's been inserted. Light well's gone in to sort of get extra light into the longer space at the back. And they've had fun with dowels. So this is just exactly the same as this material put through a doweling machine. So that's all then converted into rounds. Porter Timbers have been doing this for 50 years, making these dowelled materials and circulating around the country. This is a very nice little house constructed in the north of the state by Phil Dingemans, who's also tutors with me occasionally at the university. So Phil's selected blackwood for an internal floor and then celery-top pine for the ceilings and carried the celery-top outside to give you a continuity between one surface and another. Now the thing about the celery is the celery's got better durability than most of the other species we've got available. So you couldn't actually do that with Tas oak. Well, you could, but not for very long. Okay, so Tas oak outside, 7 to 8 years, 10 years, if you're lucky, in a situation like that. It doesn't have the durability to last any longer, but Phil's used then the celery-top to go through. There is a constraint on the amounts of celery-top we've got available, so you've got to work with suppliers to find exactly what it is that's available. Here's two other views of the place. This is another type of project which is much more utilitarian. It's a sports hall. There's a lot of thought goes into sports facilities to give floors that are both robust and have spring in them, because people running around need a floor that's got give, as do dancers, exactly the same requirements. So here you've got a Tas oak floor laid as an overlay on a substrate. There's probably a structure underneath, and this is probably on rubber mounts that might be on an open subfloor, it might be on a concrete deck. So the rubber mounts give you the bounce that you want, and this then gives you the surface. And this would be glued directly to the material. Miss Moneypenny's little restaurant in Noosa, New South Wales, combination of blackbutt and Tas oak. The blackbutt's used in these outdoor surfaces because it's harder and more durable. The Tas oak is then used as a stain surface inside the restaurant. So these would all be Tas oak surfaces. It's all Tas oak surfaces on the top and on these surfaces here in the middle. Wood and eating facilities, wood and tourist facilities, etc. Very strong combination because people feel comfortable around wood, and if you've got a tourist or a recreational facility, then having wood around is highly beneficial. It's also being recognised in hospitals now to try and get wood into the things. If we look at a major public building, here's the National Portrait Gallery, where you've got a Tasmanian bluegum floor throughout this whole structure, and you've then got glued Tas oak joinery all the way through the doors and the window structure. So the windows are actually glass in aluminium frame, and that's fixed then back off to the timber. The timber's expressed all the way through, so the wind posts then are all glue lam. So as are these doors and other things through the building. I've got one last project, I hope. Healesville Country Club, this is a new facility. It's a combination restaurant. It's got combination country club, resort, accommodation. Lot of blackwood surfacing all the way through, blackwood floors, blackwood faced columns. You've also then have these screens. So these are blackwood solids, then supporting on a stair rail with a lot of joinery around the face. And you've got, in the bathrooms, then you've got this lovely black speck detail that's been used throughout quite a lot of the accommodation. So the features becoming more important in a lot of these facilities because it's not bland, it's not predictable. Okay, so availability and suppliers. There's a number of suppliers in the room who will be more than happy to stand near samples of theirs while we get a drink. Thank you.